NIMS has successfully recorded a video of carbon dioxide in exhaled breath. You can see exhaled carbon dioxide rising up from the gap between the person's face and the mask very clearly. We at NIMS have long explored applications for infrared light, which is invisible to the naked eye. This is one of the fruits of our activities, a cutting-edge technology that makes it possible to observe the flow of carbon dioxide gas. This is the key, a special infrared camera that has high resolution and is exceptionally sensitive. As you may know, different gases absorb infrared light with different specific wavelengths. Thus, the infrared camera produces an image with bright and dark patterns, in proportion to the gas concentration. Carbon dioxide gas absorbs infrared light with a wavelength of 4.2 micrometers. If we can focus on just this wavelength, we can produce a clear, high-contrast map of carbon dioxide concentrations. The camera NIMS has designed is equipped with a cryogenically cooled filter that only permits the transmission of light with a wavelength of 4.2 micrometers. By combining this cold filter with the high-performance infrared camera, we are able to observe the flow of carbon dioxide gas using equipment with the highest infrared sensitivity in the world. Let's observe the large amounts of carbon dioxide generated by flames under a kettle. After the flames are ignited, the kettle is engulfed by a rising current of hot carbon dioxide gas. At other wavelengths, this gas flow cannot be observed. Indeed, what we see on the left is the carbon dioxide flow. Now let's observe human breath. She is breathing continuously through the mouth. You can see a slight airflow toward the front. After image processing to highlight the different gas concentrations, the flow becomes clearly visible. Each frame shows a high-contrast gas pattern like this, which reveals the slightest differences in carbon dioxide concentration. Let's examine how this flow is modified by wearing a mask. This is a typical disposable mask made of non-woven fabric. A stream of carbon dioxide gas rises from the edge of the mask. When compared with the maskless image, you can see that the flow towards the front has been blocked. Let's try a classic mask made of a woven fabric. The rising behavior is somewhat altered, but the front flow is also blocked. How about a mouth shield, which is sometimes preferred because it does not hide the face? There is an intense rising flow, but no forward flow. However, if the position is shifted by just a few millimeters, the shield rather promotes the forward flow of a person's breath. You may wonder why we as materials scientists have conducted these tests. In fact, we have a great deal of experience researching infrared light, including the development of devices capable of highly efficient infrared light emission and sensitive detection at specific wavelengths, and the sensing of pollutants using infrared light. Our many years of expertise enabled us to succeed in developing this cutting-edge carbon dioxide visualization technology. We made this video public with the hope that it will prevent the transmission of COVID-19. However, we should note that this video only shows airflow using carbon dioxide as a marker. Viruses themselves are not detectable using this method. Lastly, let's watch a person sneeze without a mask. Gesundheit! A sneeze is accompanied by a burst of breath. Moreover, some particles scatter out of his mouth simultaneously. Liquid water absorbs slight amounts of light at this wavelength. This enables this camera to also detect water droplets. We at NIMS work tirelessly to create new technologies that are useful to society.